Assalamu alaikum. This video is to review the concepts in 11.4. Okay, so I want to first jump with back to our popcorn example to discuss percent yield. Okay, so let's say from the do now, you have a bag of popcorn. You're putting this bag of popcorn in the microwave. Not all of the popcorn kernels are going to pop and give you popcorn. You're going to get a mixture of popcorn and some kernels that are not popped. And we talked about that in the chemistry lab sometimes, similar to this happens where for whatever reason, we don't end up having 100% of the product kind of form, right? So not all of your popcorn kernels are going to pop for whatever external reasons that we cannot control, the microwave temperature, the rotation um of the microwave plate, etc., the speed of the microwave plate, etc., etc. There's a whole bunch of different factors, right? That make you not get 100% of the popcorn kernels popping. And so if you look at this image over here, this is an example where, maybe in baking, I'm making a custard and custards have egg in them. And when you heat up egg, you end up having a little bit of like egg proteins that clump up. And so in order to have a really nice smooth custard to put inside your kunafa, you need to strain the custard. And when you strain the custard, you will still have some of that custard remnants on the strainer. And so what that does is now you don't have 100% of the custard that you started with. You have some remnants that you threw out in the garbage. And so this happens in the lab where sometimes chemicals, grab onto filter paper, or they may grab onto the lab table, or a little bit of it may, evaporate into the air, etc., etc. And that brings us to percent yield, which gives us the efficiency of the chemical equation. So percent yield is how much you actually got out of the equation over how much you were supposed to get out of the equation, how much you can assume you are supposed to get out of the equation, and making that into a percentage. So timesing by 100. So back to the popcorn percentage, back to the popcorn example. Let's say you have a bag of popcorn and it weighs 16 ounces. That's the total weight of the bag of popcorn. It's 16 ounces. After it popped, the kernels that you had left over, you had some kernels that were left over, you had some beautiful popcorn that, came out of the popcorn bag, right? But then you had some kernels left over, okay, that didn't pop. These kernels weighed 4 ounces. If the whole bag weighed 16 ounces, that means the actual amount that popped, if this whole bag is 16 ounces and the kernels are 4 ounces, then how much, did this weigh? How much did the popcorns weighed in total? And the popcorns in total weighed 16 minus 4, so 12 ounces. So we actually had 12 ounces of popcorn. That was our actual weight. So let's look at the questions here, and then we're going to tie this back to the chemistry. But it's good to kind of see a very simplified version so you understand exactly what you're doing with the more complicated chemistry questions. So part A in this question is how much was the actual yield? We already solved that. So the actual yield, how much actual popcorn did I have? That was 12 ounces. So 12 ounces of popcorn. That's how much was the actual yield. What is the percent yield? So percent yield, the formula is actual yield over theoretical yield times 100 because we're trying to make it percent. Okay, so my actual yield, how much actually came out, and these always need to be in mass, and mass is in grams. So how much actually came out was 12 ounces. So 12 ounces actually came out. What theoretically should have come out? Well, my bag weighed 16 ounces. So theoretically, in a perfect world where no external factors make changes to what we do in life, in a perfect world, you should have had 16 ounces of popcorn. You should have popped that bag of popcorn, and every single one of these corners should kernels should have popped and given you popcorn. So in total, we should have had 16 ounces. That's the theoretical yield. How much theoretically should have come out? 16 ounces of popcorn should have come out. How much actually came out? 12 ounces of popcorn came out. And then we're going to do times 100% here. So we go to our calculator and we do 12 divided by 16 times 100, and that gives us 75%. So the percent yield is that 75% of the popcorn was actually, of the popcorn kernels were actually popped. Okay, so um that is your percent yield idea. This is the idea. The idea is that how much is actually happening in your chemical equation. So 75% of the popcorns are actually popping in this bag. Okay, now let's apply that to these examples. So let's first start with this first example here. Okay, so zinc reacts with iodine, and I has this too because it is a diatomic element. It is Brinkelhoff. Zinc, iodine. Okay, so that equation is balanced. I don't need to do anything with that. You always need to start with a balanced equation. In this case, they gave us a balanced equation. We're good. The first question says determine the theoretical yield, and theoretical always yield always is talking about your product or one of your products. If you have multiple products, in this case we have one product. If you have multiple products, then it will identify which one is the product that's talking about. Okay. Determine the theoretical yield if 1.91 moles of zinc is used. Okay, so theoretical yield is asking me number of grams of my product. In this case, my product is zinc iodine. That is what the question is asking. You need to understand what the question is asking. When it's saying theoretical yield, it's asking you how much grams of your product. Okay. Now when I'm trying to find how many grams of my product, I can only use what is given. And what is given is 1.912 moles of zinc. If I want to move from zinc to zinc iodine, I need to keep that in mind when I'm canceling out moles of zinc here. I can put moles of zinc iodine here. And this is nothing new. We've done this before. You can put moles of one element over moles of a different element or compound. And I get these numbers from my balanced equation. In front of zinc in my balanced equation is 1. In front of zinc iodine in front of my balanced equation is 1. Okay, now this gives me 1.912 moles of zinc iodine. Beautiful. Okay, now the question is asking me theoretical yield. Theoretical yield is number of grams of zinc iodine. Okay, I got zinc iodine, but I need it in grams. So I need to change this from moles to grams. So I need to bring this down one more time. And I'm changing it. I'm canceling this. This part is automatic. This part is whatever you have here, you're trying to cancel out. And I need to change it to grams. So I can put grams of zinc iodine here. Grams over moles is molar mass. So this is where I take out my handy dandy periodic table and I see where zinc Zinc is right here. It's 65.3. Okay. And I go ahead and add that 65.3 plus 2 times iodine. So, because iodine had a 2 on the bottom. So, iodine is here. It's 53. So, 2 times 53. I add that together to get a total molar mass of 171.3. Sorry, I think iodine was, let me just go back and double check what was iodine. Iodine. Yes, I'm sorry, I was looking at the wrong number. Iodine right here is 127. So 2 times 127 plus 2 times 127 is going to give me the iodine plus 65.3 is going to give me the zinc. I get a total of 319.3. Beautiful. Now I multiply these numbers times 1.912 and I get 610.5 grams of zinc iodine. Did I answer my question now? Yes, because that matches exactly what I was looking for. I got zinc iodine and I got grams. That is the theoretical yield. So based on the chemical equation, before my chemist starts mixing these chemicals together, I can assume, I can make an educated guess that he will end up with having a product of 610.5 grams of zinc iodine. That's what theoretically should happen. So theoretically, we should have 610.5 grams of zinc iodine. So now I need to do part B, which says what is the percent yield if 515.6 grams of product is recovered. Recovered means it was actually made. So what is the percent yield if actually 515.6 grams was made, was recovered, meaning I was able to receive it from the chemist. I went into the lab and I said, can you give me the, zinc iodine that was created? So I recovered 515.6 grams. So that is what actually happened. I actually went to the chemist and said, hey, can you give me what you made? And he gave me 5.15. So percent yield is the actual over theoretical times 100%. So he actually made 515.6 grams of zinc iodine. And my equation said I should have made 610.5 grams. So I divide those two and multiply by 100. And that is going to give me, when I divide those two and multiply by 100, I get 84.4%. So this tells me that the equation is basically going to give me about 84.4% of what I was expecting to make. Okay, so I can expect to make 84.4% of, don't forget your units, of zinc iodine if I use this equation. Okay, that's how you do part A and part B. Guys should pause these videos, try these on your own, and then go back to the problem, try it on your own, and go back to the video if you got stuck at any point. You should not just be watching the video. That doesn't really help if you're not practicing. So the whole purpose is for you to kind of learn how to do it, try it on your own, see if you get it. If you don't, go back and rewind, um, and just keep doing that in a cycle until you get it. Okay, let's do another type of problem. This is very similar. The only difference here is that now we have two products. that end up happening in this mixture. And additionally, they give you grams. In this case, they don't give it to you as moles, whereas in the first problem that we talked about, um, they gave us moles to start with. Okay, so let's get working on this one. So silver chromate forms when excess potassium chromate is added to a solution containing 0.5 grams of silver nitrate. Okay. Determine the theory. So what is given? What is given is 0.5 grams of AgNO3, which is also known as silver nitrate. So that is what is given. So we do need to identify that right away because that's where we start. Okay, now let's look at the question. This is a balanced equation, so I can move on to the questions. If it's not balanced, then you need to pause and balance the equation first. Okay, so let's do part A. Determine the theoretical yield. Again, theoretical yield means the number in grams of your product. In this case, there's two products, so they identified which product we want to know how many grams we're going to get. And so this is the product, which is the silver chromate. So we're looking only at silver chromate. We're not looking at potassium nitrate there. We're looking at silver chromate. Okay, so how many grams of silver chromate? Okay, so how many grams of silver chromate am I supposed to get from this chemical equation? Well, I always start with what is given. Okay, what is given is 0.5 grams of silver nitrate. I cancel what is given, silver nitrate. Okay, the only thing that I could put on top of grams is moles of the same thing. So moles of silver nitrate. This is molar mass. The molar mass of silver nitrate is 169.87. I divide these numbers and I get 0.0029 moles of silver nitrate. Okay, did I answer my question? No, I'm looking for a totally different compound here. This is different than what I'm looking for, so I need to bring this back. And I need to cancel out the AgNO3. And I need, instead of AgNO3, I need to get it in terms of Ag2CrO4. Moles on top of moles means I look at the balanced equation. So moles of AgNO3, 2 is in front of it. Moles of Ag2CrO4 is 1 in front of it. I divide. I get 0.0015 moles of Ag2CrO4. Okay. Whoop. Okay. All right. I finally got in the compound that I want in my answer, but it says I need grams. So I have moles. So to get rid of moles, I'm going to do one more. I'm going to get rid of moles of Ag2CrO4. And I can put grams of Ag2CrO4 on top. That means this is molar mass. Ag is 107.87, so 2 times that, plus CR is 52, plus 4 times 16 gives me a total of 331.74. Actually, when I did the math, I got over here, this was 0.00147. I rounded too much. So 0.00147, sorry, times this number gives me 0.488 grams of Ag2CrO4. Did I answer my question? Yes, I got grams and I got Ag2CrO4. I got the actual amount of the product. So this is my answer for part A. So When you start with grams, when they give you grams of something, it's a little bit more steps, but it's the same exact thing that we've been doing. You just need to, be organized and not lose focus of your goal. Theoretical yield means you're looking for grams of the product. And if there's more than one product, they're going to tell you which product you're looking for. Okay, so now let's do part B. Part B is very easy. It's actual over theoretical. So it's saying percent yield. If the reaction yields, so if actually we have, that's what this means. If the reaction yields, so if we actually end up having 0.455 grams of Ag2CrO4. So if actually, so we do actual over theoretical times 100%. Okay, so if actually we have 0.455, but theoretically using the chemical equation, we got this times 100%. What is the percent yield? And when you do that math, you get that the percent yield is 93.2% of Ag2CrO4. That is your total percent yield. So we get about 93% of the product anytime we do this type of chemical equation. All right. Inshallah, you guys should, try the problems on your own. You also have a homework worksheet to work along this. Try the problems on your own. Go back and review a part that didn't make sense to you, and try to get the answer, and then play it back so that you can see if you got the answer. Thank you. Wassalamu alaikum warahmatullahi wabarakatuh.